In this lecture, we're going to create some API tests. And by that, I mean we're actually going to start up our application and then make HTTP requests to that application and check the responses. For example, we'll want to verify that the ping route really does return a 200. And by doing that over HTTP, this kind of integration test or end-to-end test is testing that all the intermediary steps, like processing the user's request and being able to spit out JSON, those must be working if the API itself is returning the expected result. So we're going to start by creating another file next to the unit.js file, but we're going to call it api.js. So I'm going to say touch test api.js. I'm going to open this up and say that this file is going to contain the API tests. This is going to have a number of dependencies. The first is going to be the app itself. Like I said, we need to start up the app, which is not something we've done from a test before. So we actually need to require the index file from the root of our directory. We need the assertion library as before. We're going to need the HTTP module in order to craft these HTTP requests. And we're going to need our config object. The config object is going to tell us which port that we should actually make our HTTP request to. Before we fill out the rest of this file, let's actually go to that config object and create a separate configuration block just for testing. So I'm going to copy our staging environment and say that this is going to be the testing environment. I'm going to paste it down here. And the only difference that we want to make is that we want, when in testing mode, HTTP port to be 4000 and HTTPS to be 4001. The env name is then going to be testing, but everything else can stay the same. So now when we start our app in testing mode, it's going to be running on 4000. Or to put it another way, if we see the application running on 4000, we know that it's in testing mode, not staging. We, of course, though, need to change this key to be testing as well. Okay, now we actually need a way to tell the application to run in testing mode when we start it up. We could do node.env equals testing, but we want to just be able to call node test without having to remember anything else from the command line. So I'm going to go to our test runner here, and the first thing I'm going to do is override the node.env variable. We do this by just saying process.env.node.env equals testing. Now, no matter what somebody set when they did node.env and then node test, we would be overriding it to testing. So we are enforcing the fact that when these tests run, it's going to be starting the application up with node.env equals testing, which means anyone using the config is going to inherit this configuration object as opposed to the staging or production ones. Okay, now let's go back to api.js. We want to, as before, create a holder for the tests. This one we're going to call API instead of unit. And it's just going to be an object. And down at the bottom, we are going to export the tests to the runner. So module.exports equals API. Now let's write some tests. All of these tests are going to include making requests over HTTP. So rather than crafting HTTP requests by hand each time, let's just make ourselves a little helper. We're going to call this var helpers equals an object, and then this function is going to be helpers make get request. And that's going to be a function that takes in a path and a callback. We want to configure the request details, and then, if you remember, send the request afterwards. So let's configure these details. This is just going to be for simple get requests, and so we don't really need to do anything fancy here, since they're always coming to our API on localhost. The protocol is always going to be HTTP. Hostname is localhost. Port comes from the config file. Port is config HTTP port. The method is going to be get. The path is going to be the path that gets passed to this function. And then the headers are going to be content type application/JSON. And that's all the configuration we need to do. Then when we actually send the request, we're going to call rec equals HTTP module request, pass it the request details, and expect back a response object, which we can simply call back to whoever called us. Then we call rec end, which sends it off, and we're done. So that helper will allow us to write these tests a lot easier. Before we make that first HTTP request, we actually need to include the app and start it up. So we want to say that the main init function should be able to run without throwing. So we're going to write this like we did those other does not throw functions before. We want to call API app init should start without throwing. It's going to be a function that takes done. We're going to call assert does not throw, and within the does not throw of type error, we are going to just call app init and expect a callback after init is done booting up. After init is done, we want to call the done. Now, one thing you might be remembering from our index.js file is that app init doesn't call back anything at all. It does 3 different things. One of them is set off by 50 milliseconds. So in order for this test to ever reach the done, we're going to need to add a callback to app.init. So let's do that now. Within the function declaration, we're going to include callback. And then within the set timeout, we're going to call callback, because that should be the last thing that happens out of these procedures. Lastly, when we call the execute, we can't just invoke app init because it's expecting a callback, so we have to call app init and then pass it a callback that doesn't do anything. But one of the other things you'll notice is that we are requiring the application here and then asking it to start up, which means we don't expect it to start up the moment that we require it. We don't expect this file to self-execute. We expect it to simply export itself and wait for us, some third party, to call the init function. That's not how this primary index file works. This index file defines its own init and then calls itself, which means our tests would never reach this point. It would never be able to call init, because the moment that it included var app, this logic would run through and self-execute. So we need to use a trick that's built into Node to tell this file only to self-execute under certain conditions. And those conditions are that someone is invoking the file directly, such as going to the command line and calling node index.js. If they're invoking that directly, that means they're trying to run the application. If this file, on the other hand, is being invoked indirectly, which means some other file is including it, our test runner is including it and then trying to invoke it, it should not self-execute. So let's change this comment to self-invoking only if required directly. So let's say if require dot main equals module, then we want to self-execute. Now, this is just a quirk of the syntax built into Node. What this is saying is, if you're invoking me directly, my module is going to equal require.main. If this file is being invoked from another file, and that other file is the one that's being called from the command line, these two are not going to equal each other, and so this initialization function will never happen. So let's go back to api.js. We've modified init, and told init not to start unless we tell it to, when we're invoking it from a separate file, such as we're doing here. Now that we've started the application up, and we've waited for it to start all the way up, we can make a request to ping. So let's say that this test name is /ping should respond to get with 200. And this is going to accept a done. And it's going to call our helper. So it's going to say helpers.make get request. The path we're going to tell it to hit is /ping. And we're going to expect back a response. When the response comes back, we are going to assert the equality between the status code, which is available at res status code, and the number 200, which is the same as saying the status code should equal 200, throw an assertion error if that's not true. And then we're going to call it done. Let's make another request. Let's copy this down. Let's make a request to API/users. Since we're making a bald HTTP GET request with none of the required fields, this should call back a 400 to us. So make a request to API/users. We want to say that API/users should respond to GET with a 400. So I'm going to modify this path, API/users, and assert the equality between the status code and the number 400. To hammer this example home, let's make a request to a random path. And we want to say a random path should respond to get with 404. And we want to make a get request to this path shouldn't exist. And then we want to assert the equality between the status code we get back and 404. Okay, so those are all the integration tests that we need. As you can see, it's very easy to get the status code. It would be just as easy to get the body text or the response headers or anything else from these requests. And if you did so, you could validate all kinds of things. If you wanted to validate that the payload that the API is returning should include certain keys or should have certain values, you could do that there. If you wanted to scrape HTML pages and assert, there should be a head or there should be a body or there should be this div or this span inside of this HTML, you could parse the HTML and do that there. In this way, these kind of API or integration or end-to-end tests can be used to validate your HTML pages, your JSON responses, and everything else that your API or your user-facing web app is doing. Before we call this, though, we actually need to modify our test runner just a bit more because we're not including the API test. So we want to say that app tests API equals require API. And then at the very end of the test report, after we console log that we are ending the test report, we want to kill the process by calling process exit 0. This is because within the API test, we have started up the application, and there's nowhere else in the code that is explicitly stopping it. So this will explicitly stop the app from continuing on in any form after the test report runs. Let's go ahead and run these tests and see what happens. I'm calling node test, and you can see that we have a number of issues here. We have the errors that we expected in the get a number and the debugging problem in it, but we're also getting that there's an issue with the get request to ping, which there shouldn't be. And it looks like that is a similar error that we've hit before. HTTP is not a supported type. We actually need to make it HTTP:. So I'm going to edit that here. And we're going to clear out these tests and run it again. Okay, now this is looking good. We're seeing a lot of green, and we're also still seeing the blues and pinks and yellows that we are logging out when we're booting up the application. That is because the application is being started up by the test runner. It runs through all these tests and is telling us that there are 2 failures, and it's the same 2 failures that we experienced before: get a number and example debugging problem. And so all of these tests seem to be running fine, and that's all we need to go over as far as adding tests and debugging and linting to our application. If this was a production application, you'd obviously want to go through all of your files, all of your libraries, all your functionality, and write tests all over the place for everything that you can. The more tests that you write, the more solid your application is going to be. And the more easily and quickly you'll be able to tell if and when you do accidentally break some functionality in the future, because your tests will start failing. So now we can move on to the section review.